We will do this section by section, so if you have questions from the first page on numbers 1 through 6, or the last page, numbers 1 through 4, we'll go like that and then keep on. Do we have any questions in this first section on this first page? I did not mention this when we were going over GCF originally, but we should, anytime we see a negative, also factor out that negative. This is factorable. There we go. Same thing as the cycle. So look for something that each of these have in common. I mentioned last class that you can use your calculator, go into math, scroll over to number, and find GCD number 9. But you can only do 2 numbers at a time, and you wouldn't use the negative. You just put in 6 and 42. And then try and see what the GCF is of the last 2. So I did it again, math, scroll over to number, go down to number 9, and do 42 and 3. So if these 2 are different numbers, look and see could the lowest number is going to be the one you use. So 3 could go into 6, so 3 is going to be what we use. But you would make it negative because this is negative. So we're dividing everything by negative 3. These also each have an x, so you could divide each one by x as well. This part, writing this part is not necessary. What's really necessary is writing the 3x outside of parentheses, dividing each thing and seeing what's left. So all of the signs are going to change. You have a positive 2, and then your exponent just drops down 1. So x squared minus, whatever that is, minus 14x, and then plus 1. However many terms you have when you factor out the GCF, you should have that many inside as well. Questions on that one? Any other GCF problems on this page or on the back page? Next section, grouping. Questions on the front page. 10. And I know what were you going to say? Which one? 10. Okay. So you can do this one of 2 ways. You can look for a GCF first, because it might have one, or you could do it at the end. It does not matter as long as if it has one, you get it eventually. So if you do it first, you have to find the GCF of each thing. I could do that in a calculator, find the GCD of the first 2, 15, and 10. And then find the GCD, which is the same thing as GCF of the last 2. And 8. These are 2 different numbers. I just said the smaller would be the one, but I can't divide these by 5 and these by 4, so it has to be something else if there were a GCF. Because those aren't the same or one can't go into the other, there's not a GCF for all of them. But that also helps you with the next part since you have to split the middle. We found the GCF already to be 5. And these both have at least 2 x's, so I can make that 5x squared that we're dividing each thing by. And I would have to see what would be left when I divide those. So this would give me 3, just 1x minus 2, and there would be no x's left there. Of the last 2, we just found that GCF to be 4. Whatever this sign is, we need to bring that down, so negative 4. These don't have x's in common. So this would, when we divide, would be positive 3x minus 2. You want your inside pieces to be the same. They should be the same regardless. If they're not, double check your math. But if they are the same, that becomes one of your factors. And then everything outside becomes your second factor. The GCF is used a lot, all over the place. Questions on that one or other questions in this section on this page?
You do 8.
So that one would be one where each one, because these are the exact same numbers, whatever we find the GCF to be, it's going to be the same GCF for everything. So that means I could divide everything from 8 from everything. So it means everything has a GCF of 8, so I'm going to take care of that first, get rid of that from everything, so that we have 6x cubed plus x squared plus 6x plus 1. 6 and 1 don't have anything in common. But now I'm going to go on to the next step, do this, split the middle. Keep bringing down your 8. I know 6 and 1 don't have anything in common, but they do have multiple x's that they share. So x squared would be my GCF, and then I would subtract my exponents. This would go down 1, it would still be 6, so 6x. These would cancel, but leave a 1. What could I divide out of those last two? 1. Just 1. So if nothing else, always 1. And then the inside would stay the same. So then when you write your final factors, 8 will get brought down. You have these outside pieces, x squared plus 1. And then the inside pieces, 6x plus 1. So we found the GCF at the beginning, but if you had just started with splitting down the middle, finding the GCF of the sides, and keep going, you would end up with one factor that's like, I don't remember what it is off the top of my head, but it would have something where we could divide out of it again. And that would tell you, I didn't find the GCF at the beginning, I need to do it now. Questions on that one? Or other questions in this section or in the on the back page in that section? 12. Okay. Yeah, that one's easy. When you see big numbers like this, find a GCF. See what do these have in common instead of trying to go forth with it. We have 192 and 336, 48, and that's the wrong thing. 168 and 294. So 48 and 42. One doesn't go into the other, but they can be broken down further. Let's see. 6. I was going to say, you could do the GCF of these two if you get something like that, and then it would be 6 because I could divide both of them by 6. If also, so you could use that method every time. You could also start listing out the factors of one of the numbers. Pick one of the numbers and start dividing each of the terms by that number and see does it work or does it not. Both ways are kind of time consuming, so that's up to you. X to the third minus 56 x squared plus 28x minus 49. So these numbers are still big, but they're not as big as they were before, so they're a little bit more manageable. And then same as before, split the middle, find the GCF of the first two. I'm just going to keep using this. Number 9, 4, 32, and 56. So 8. And these each have x's, so I could take out 2. Always look at the smallest exponent, that'll help you. And then divide that out. So you have 4x minus 7. And then you could do the GCF of this. It should be 7 though. Thank you. So plus 7, leaving us with 4x minus 7. And then you would rewrite it. Keep the 6 on the outside. Put the outside factors together. 8x squared plus 7. And the inside factors together. 4x minus 7. So grouping is just a lot of GCF, really. If you're good with GCF, just do that multiple times. Questions in general with grouping. Okay. This says PS is perfect square, but it's really difference of squares. So any of those, 13 through 18, on that first page. 15. I heard another number. 16. Okay. Always check for a GCF because there might be one. In this case, I know there's not because the factors of 9 are 1, 3, 30, and 9, and 25 doesn't have any of those except 1. So then, if it doesn't have a GCF, you know you're going to have 2 factors. Look for what times what will give you 9x squared, and that would be 3x. What times what will give us 25, and that would be 5. And put a plus and a minus in between. These should be identical except for one's a plus, one's a minus. (16) Same thing. This doesn't have a GCF. To get 4n squared, that would be 2n. And then we just did the 25 was 5. So one's plus, one's minus. It doesn't matter if the plus is first or second.
Thank you.
Any other difference of squares? 18. So here, no GCF. To get p squared, we would multiply p times p. To get 1, we would multiply 1 and 1, the plus to the minus. Okay. On to the back. Questions on objective 4. So remember that this section is different than objective 5. You're looking for 2 numbers that multiply to be the last. That should have been times. And add or subtract to be the middle. So find factors of the last. In this case, there's only one set. And think about how you could add or subtract them to make this -3. How could I make them -3? They both have to be negative. So, if this is positive and this is negative, these both have to be negative. You may have to change your signs.
Best autumn song.
Diego, phone away. Caleb's phone away.
Just like me.
So then you're going to have two factors. Whatever your variable is, put that first. And then put your two numbers
My
in.
mind, buddy said.
What?
So the hardest part about these ones is finding your factors, finding which ones work.
Does the order really matter?
No, it does not. So you could put x minus 1 and then x minus 2, it would not matter. Other questions in this section?
24.
So 24 is similar. Two numbers that multiply to be 64, add or subtract to be 16. If you don't know the factors of 64, start dividing. You can always start with 1 and 64. It's even, so 64 divided by 2.
8 times 8.
Okay. You can see if 3 works. Nothing more than 8, so see if 4 works. 5's not going to work. See if 6 works. See if 7 works. 4 and
65. Wait, no. 4 and 16.
4 and 16. Does 7 work?
No.
No. And then does 6 work?
No.
No. So then that's it. Which of these, if I added them together, would give me 16?
8 plus 8.
8. P plus 8 and P plus 8. 23 has a number in front. And if it's in this section, look for a GCF. It's most likely this one. So divide everything by 3. And then keep going. Okay. Let's move on to the last one. It's the last section. Questions in that section. So this is the one with the most steps. 26. Okay. Again, if you have big numbers, see if you can divide them each by something. So I'm going to look at GCF of all of those.
Worst day is this.
So it's 35.
I'll play it in the car.
I'll listen to you.
You want to go?
And 100.
Tory Lanez.
And 100 and 160.
This puts me in my feelings.
I'm saying
Makes me want to cry and die.
the color violet or whatever.
So between these two, 5 goes into 20, so it's going to be 5.
Shit is
So I can divide each of these by 5.
Imagine breaking up with your kid. He drops that song.
So
So good.
I don't know what that is. 32. And then we're looking for, we need to multiply these two numbers, 7 and 32.
224.
And then we need to find two numbers that multiply to be 224, but add or subtract to be 20. So, because this is a big number, you may want to start with something you may know. Like starting with 2 may not be a great number. I always go to 10. I just go to that. I know it's not divisible by 10, but I could then go up or down from there. So let's start at 9. Okay, no? And then just keep going down. So 8 and 28, if we added them together, somehow could we get negative 20?
Yeah.
Yes. And that was by pure guessing. I just did that. We don't need to find all of them if you find what works immediately. How could I make this negative 20?
28 plus 8.
Would 28 plus 8 make that?
Negative 28 plus 9.
Negative 28 plus 8. Okay. So then we rewrite. Keep bringing down your GCF. Leave the first and the last. 7k squared put these two numbers in. It doesn't matter the order. Make sure they have the variable. So negative 28k plus 8k minus 32. Remember the space there. Once you find your factors, that's probably the hardest part about this part, and you rewrite it, then it's just like what we were just doing. It's your grouping all over again. Split it down the middle, find the GCF of these two, of the first two. We could divide them both by 7 and k, leaving us with k minus 4. These last two, we could divide them both by 8, so plus 8, leaving k minus 4, and then rewrite everything. 7k plus 8, k minus 4. We can start one more and finish it when we get back from lunch. Which one? 29. Okay. I want to say this has a GCF
forward.
Maybe it's just
of 3.
Huh?
Maybe it's just not them.
Flip a coin.
Wait, just go.
Chess game. If you lose, it's your call. Make the wager. Make the wager.
Yeah. So we can
Yeah, let's try
divide
to-
everything by 3.
What did you say?
Like, she posted on her story how she's about to get drug tested.
No. Oh, I hope you have good luck.
She was like asking me like how long it took me to pass.
She never
And
opened
then someone multiplies 6 and
Then she was
negative
like,
14
I
will
was
solve
like,
it.
send me a picture of your drug test. She'll pass. And she was like, alright, cool.
it. Just don't say
Then she
anything.
just never.
84.
84. And negative 84. So we'll find factors of negative 84 when we get back.
On the way.
Diego, come away.
Be dark.
Perhaps.
Okay, so we have to find factors of, I said negative 84, we need to find factors of 84, so we know 1 and 84, it's
Just tell me for the
even,
lights
so
going.
divided by 2,
Miss Lord.
yes.
I think I left my phone in the lunchroom.
No, I have
Yeah.
Thanks, Bookie.
And it's divided by 3. Yes, 3 and... 3 and what? Okay, what about 4? 4 and 21. 5 wouldn't work, what about 6? Closer.
Thank you.
7? 7 and 12. So I think those...
4 and 21.
8. You said 4 and 21. Yes, that would work. If we made 21 negative. So then, just like the last problem, rewrite this into 4 terms, leave the first and the last. And put in, it doesn't matter the order, 4x and negative 21x. Split it down the middle. And find what could be divided out of these two.
2x.
2 and x. Leaving 3x plus 2. And then what could we divide out of these two?
7.
7, but it would be negative. So negative 7, leaving 3x plus 2. Sorry, that's really smushed over there. We have 2x minus 7 and 3x plus 2. We have general questions or questions about that problem. your phones up in a pocket, not in your pockets, not in your book bags.